Thanks a lot, Claude. Good morning, everyone, and happy to be here today. My pitch will be about sharing with you some AI applications that we are implementing with our clients in aeronautics, defense and space sectors. So I'd like to start with this picture because 1 month ago, I think we were all impressed about how SpaceX succeed in recovering the Starship, the Starships, so the ESA wrote a paper 2 weeks ago about even if the mechanisms are not publicly released, that's a great example of how AI, and especially a reinforcement learning complex model of AI, could be used to process and to achieve precision and complex situation in real life. So that's really impressive in terms of use. Obviously, and to be honest, all the use cases we are doing are not that level of complexity and of industrialization, but we will then have a glance of what is achievable with AI today in those sectors. So first of all, I'd like to start with some figures about where the sectors, aerospace and defense, is and where, because every year the Capgemini Research Institute is doing an executive survey to see how the AI, and here the generative AI, but the figures are closely the same, is evolving in the capacity to use and enable AI in different use cases. So last year, aerospace and defense was in the average of the sectors in terms of adoption of AI and generative AI. But we see that this year, in 2024, there is a huge acceleration of how the sector try to implement and to take some pilots about the use of this technology. So, and is today the highest Gen AI pilots sectors, right, among all sectors. So, but if you see closely the figures, you will see that in terms of pilots, there is a lot. But in terms of concrete enablement in a lot of function and in a lot of use case, there is still some difficulties to put this AI in production in critical systems, and we will see some of the example of why. So first, and that's why we love to make AI in aerospace and defense. It's because it's one of the most fertile playground, but also one of the most complex. So first, it's a very data-rich sector, maybe one of the richest one, because there is sensors, there is image, there is text data with reports, with intelligence systems that give, let's say, a lot of nurturing for the models, and especially for the machine learning and data-driven AI that Juliette mentioned before. The second point is that this sector is really having significant transformation. We have some piece of this about the status of the defense right now, but there is also some transformation in terms of sustainability in the aeronautics. So that's clearly need for doing innovative stuff and support this transformation. And of course, there is new competition. There is startups, there is innovative players that's trying things, that's doing new things with AI and with other approach, and that helps to create this innovative environment. But there is, let's say, 4 main challenge that we see when we are doing AI in aerospace sector. First is the difficulty to have a validated, safe and reliable system, because doing AI in such sector is not like, you know, doing AI for marketing, or you can push an email. It's not a big issue if somebody received the wrong email, but here you are trying to incorporate AI in critical systems, and that's not the same job than just learn that just train and use an algorithm. Second point is about cyber defense and vulnerabilities. Of course, it's a difficult sector with cyber threats, with a question about system resiliency, and that brings some additional technical requirements when it's about developing some AI algorithm. I will not take so much time on ethics and trustworthy AI because that wasn't faced before, but that's also something we need to have in mind when we are building AI algorithm. So first, let's have a bird's-eye view about AI applications for the aerospace sectors. We identified three main game changers, three main topics where we use and we see our client using AI. So first one is sustainability, and I would just after do a quick deep dive about one use case we did this summer with one of the leaders in aeronautics in France. So it's about optimizing the flight pace, it's about helping R&I teams to develop new material, to optimize current process. The second point is about air traffic and safety management, mainly on how to improve availability of the planes, about how to deal with the increase of air passenger that there is in front of us. And the last one is about operation excellence, like in all sectors, and especially manufacturing and aerospace sectors, where we use AI to improve the production process, to improve the fleet management, and to try to optimize all those processes. So let's have a quick look about a project we realized so last month. It's about how we can use AI and especially computer vision to better understand contrails effect. Because when we are talking about greenhouse, we often start with CO2 emission. That's the KPI everybody is following. But emerging studies show that contrails have also a huge impact on greenhouse effect. So our client wants to use AI to better understand and to give tools to his R&D team to have more information about this phenomenon. And where it's interesting, it's because even if you are looking to this phenomenon with satellite, with airplanes, having a ground observation unlock, let's say, three main advantages. The first one is that you are able to contextualize easily the information you see with additional data. You are able to get the flight number, to the altitude, all the information you need to better understand this phenomenon. The second point is that it helps to have a ground truth for the other observation system. You can cross what you see from the land from what you see from the sky. And the last point is to have it real time with higher definition sometimes because you have landed cameras with specific protocol of acquisition that you can adjust depending on the phenomenon. So thanks to this, and thanks to our colleague of Capgemini AI and Capgemini Engineering, we are able to get these data sets, to record it, to cross it with some metadata, and then to reuse it to train a model in order to detect contrails. So that's really interesting, even if it's still an experimentation so far. We get some, let's say, interesting first results, and that we see that where the model underperformed is clearly where we need some more labelization and stuff that expert will help us really quickly to face off. And so that will provide for this aerospace leader new information to be able, for example, to adjust dynamically the path, to be able to avoid some weather condition that create this kind of contrails, and to dynamically try to reduce the greenhouse effects. So that was the first example. So now I will go quicker on the defense sector. We regroup the use case we see under three buckets. So the first one is about ISR, with especially all about analyzing quicker, more volume of data. It could be images, it could be text, whatever, but AI is really great to do so and to help operators to do so. The second point is about autonomous systems. So today, drone swarm is becoming, let's say, something really classical in the army force. And so AI is really great to help those kind of use cases. And the last one is about how we can help logistics and resource optimization on military budgets, especially to find the good level of support between budget and reliability. So three quick examples. So that's mainly public. So it's sourced from the internet and from projects that we are working on. So the first one is, how I said, using GenAI, NLP and LLM to help command and control to better analyze all the open information that you could have available to take some decision about a situation and recommend some course of actions. The second one is about improving the orchestration on the drone swarms and also to identify some patterns about the situation that also help the deciders and the operators to take decision in real time. And the last one is one that had been awarded in last Euronaval showcase about how we can use AI and time series analysis to better understand the firing system embedded in a naval warship. So that's opened a lot of constraints and difficulties, because it's not like having an hyperscaler to run it and to train and to infer the model, but that's clearly a kind of example that could help to improve the availability of some systems. That's the conclusion. So perfect. Last, and just to conclude, today all those use cases are globally well known about the industry, by the industry. The challenge we have now is how to break this industrialization wall we have in front of us. So first, how we are able to better integrate AI into system, and that's a question of skills, because data scientists so far are not system experts, and especially in high security expectations. So how we are able to hybrid these competencies and these skills to put AI in productions. Trustworthy AI has been showcased before, and of course, new opportunities with Gen AI and agentic AI to come. Thank you.
Okay, thank you. Frankly, it's concrete, I would say, links with real application that interest us, I would say, really.